So today we are doing something that is 100% review from Algebra 1. We're going to be on Unit 1 and 2.5. And this is Systems of Equations. Systems of Equations. There are actually 3 different ways that you can solve a systems of equations. And the whole goal here is to figure out if you have 2 lines, where do they cross? That's all we're trying to figure out here. So the first way is what we've already done. We've actually done graphing. And graphing, whenever you graph something and find out where they cross, that is one way to figure out where 2 lines would intersect. Another way is called the substitution method. And you should probably, substitution. Felt like I had too many letters there. Substitution method. You should probably remember this from Algebra 1. I hope that you remember this. And in the substitution method, the key, or what your goal here, the key is to get a variable. Key is to get a variable in one of the equations. Key is to get a variable in one equation by itself and plug it into the other equation. So you are literally substituting one whole equation into the other equation. So you're going to see problems that look like this. For example 1, if I give you that x is equal to negative 3y plus 3, x equals negative 3y plus 3, and your other equation is 2x plus 5y equals negative 5. X equals negative 3y plus 3, and 2x plus 5y equals negative 5. Now, I know they don't look like them right now, but these actually are 2 equations of lines. Okay, they're not written in y equals mx plus b form, but these are the equations of 2 lines, and we want to figure out where would these 2 lines intersect with one another. So, substitution method is when you have one letter that's completely by itself. So here, this x is 100% by itself. What we're going to do is we're going to take what x is equal to, and you're going to plug in into the other equation. Okay, so for this one, I'm going to plug in negative 3y plus 3 in for x. Anytime you plug something in, you need to put it in parentheses. Doesn't matter if it's just a number or if it's a whole equation like this, you do need to plug it into parentheses. Also, don't forget to write the rest of the equation. Okay, people like to stop right here. You still have to bring down the 5y, you still have to bring down the negative 5. Then, anytime you have parentheses, that tells you to multiply, so distribute this. Don't forget to distribute all the way into your parentheses, not just the first one. So, negative 6y plus 6 plus 5y equals negative 5. Then you want to combine your like terms, so put together your letters, together the like terms. Negative 6y, positive 5y gives you negative 1y plus 6 equals negative 5. Where would you go from here? Move the 6, so subtract 6 from both sides. If you show that work, that's fine, but you don't have to. So subtract 6 from both sides. Leaves you with negative 1y equals negative 11. How do you get rid of a negative on both sides? Divide both sides by negative 1, so y would equal 11. Now, you're only half done. Now that you have the y, how can I find the x?
Plug it into the other.
Plug it in. You can plug it into any of these equations, okay? I would use this first one because it looks like it's going to be the easiest. So from that equation, you're going to plug in y of 11. So x equals negative 3 times 11 plus 3. And then just work it out. So negative 3 times 11 gives you negative 33. Negative 33 plus 3 gives you what? Negative 30. So that's your x portion. If you stop right here, it is wrong. Okay, remember, these are crossing in a point. So I want you to write it as a point. The x part always goes first, then the y. I know that seems very simple, but a lot of people put them backwards, okay? X has to go first, y goes second. That's your answer. Now, like I said, you could have graphed these and figure out where they crossed, but that is a really far away point. So usually it's a little bit easier to do a different method other than graphing when you're figuring out where these cross. Try another one. For number 2, again, I would like to use the substitution method to solve the system 5x plus 2y equals 21 and negative 3x plus y equals 5. And I would like you to solve that by substitution. On your homework today, you're going to realize that some of it says or is giving you exactly the method that you have to use, and then other portions of your homework you get to choose. Okay, this is one that I'm telling you I want you to use substitution method. Is there a variable that looks like it would be easy to get by itself? Which one? The y in which equation? The second equation. Okay, because it's all by itself. How would you get y by itself? What would you have to do? Not make y negative.
Add 3x.
Okay, you're thinking the addition method. We're not to that one yet. So substitution method is get y all by itself first. So move over the 3x, and you would get y equals positive 3x plus 5. Then we want to take this, and we're going to plug in 3x plus 5 into the other equation, so into that first equation. So this is going to become 5x plus 2 times 3x plus 5 equals 21, and then distribute and solve. So 5x plus 6x plus 10 equals 21. Combine your like terms, so combine your x's. 5x plus 6x gives you 11x plus 10 equals 21. David, what are you doing? Write down the notes. Thomas, write down the notes. Move your 10 from both sides. 11x equals 11, and so x equals 1. Now, I know that this is review. I know this is super easy for you guys probably. The reason we're doing this is because tomorrow, or block day, we are going to add in another variable. So you're going to have 3 equations with 3 letters, and it's not as easy. So if you don't understand and you're not really good at doing the ones with 2, you're going to be really messed up by the time we get to 3. Okay, so that's why we're doing this. Even if it feels redundant, just do it. Okay? Here, what do I do to solve for y? Plug into one of the other equations. I would use this one. You don't have to. You can use whichever one you want. And you've got y equals 3 times 1 plus 5. 3 plus 5 gives you an answer of y value is 8. And where do these two lines cross? At what point? 1, 8. Remember, make sure you always put the x portion first, then the y. Anyone have any questions on that? Fairly basic?
Yep.
Yes? Write it down still. Okay, the other method, and what people usually like is, does anyone remember what the other method is called? It's called the elimination or addition method. The elimination or addition method. Okay, in the elimination or addition method, the key here is to eliminate a variable or cancel out a variable when you add the equations together. Key is to eliminate a variable when you add the equations. EQNS is the abbreviation for equations, because I ran out of room. So for number 3, I would like you to solve 2x plus 6y equals 17 and 2x minus 10y equals 9. 2x plus 6y equals 17 and 2x minus 10y equals 9. So here, instead of getting a variable all by itself, we want to add the 2 equations together and cancel something out. Okay? What do you think I want to try to cancel out in this first one?
The 2x.
The x's, right? Can I, if I add them together, will they cancel out right now? No. But what can I do to make them cancel out?
Multiply by -1.
Multiply one of the equations by -1. Doesn't matter which one. I'm going to choose to multiply the second one by -1. So the first one I'm just going to rewrite over here. 2x plus 6y equals 17. If you distribute a negative, don't forget you have to distribute to every single part of this equation. So negative 2x plus 10y equals -9. Then literally in columns add the two equations together. So the x's will cancel. 6y plus 10y gives you 16y equals 17 minus 9 is 8. If you divide both sides by 16, what do we get for a y value? 1/2. Okay, 8 over 16 equals 1/2. Is it okay to get fraction answers? Yes. You may not like them, but it is okay to get fraction answers. Then we're going to take this, plug into any of the equations, doesn't really matter which one. I'm going to choose the first one because it looks a little simpler, and plug in a y of 1/2. So 2x plus 6 times 1/2 equals 17. 2x plus, what's 6 times 1/2? 3, okay? The fractions are going to go away, so they're not going to be that big of an issue for you. If you subtract 3 from both sides, that gives us 2x equals 14. Divide both sides by 2, x equals 7. So at what point do these two lines intersect? 7, 1/2. And that is perfectly fine to have fractions, just like that. Is this coming back to you? Do you guys kind of remember this, or? Yeah, hopefully. Say again.
I said I remember this.
You remember this, yay. Okay, number 4. How about if I ask you to solve 3x minus 6y equals 9 and negative 4x plus 7y equals negative 16. I want to find where do those two lines intersect one another. This one is not quite as obvious because there's not any numbers that are exactly the same where you can just multiply by negative. Sometimes you have to multiply both equations. So first thing you want to do is decide which variable would you like to cancel, the x's or the y's?
X.
The x's, okay. What would you multiply the first equation by to cancel out the x's?
4.
Multiply by a 4. Okay, what would you multiply the second equation by?
3.
By a 3. This one you don't have to multiply anything by negative because you already have one positive, one negative. Okay? If you multiply everything through on the first equation by 4, you should get 12x minus 24y equals 36. And negative 12x plus 21y equals, what's 3 times negative 16?
42.
Negative 48. So you need to write it on the side of your paper so you don't make silly math errors. Now that you have the two equations, add them together so the x's will cancel. Negative 24y and positive 21y gives us what?
Negative 3.
Negative 3y equals negative 12. Divide both sides by negative 3. Y equals positive 4. Now, you can plug this into any of the equations, okay? It's usually simpler to start with the ones on the left. Okay, so these are usually the easier equations. I'm going to plug into this first one. That would give us 3x minus 6 times 4 equals 9. So 3x minus 24 equals 9. Add 24 to both sides, so 3x equals 33. Divide through, x equals 11. So what point do these two cross at? 11, 4. So you now have 3 different methods that you can solve by. You could graph, which is generally the least good example. It's not very, it's the worst method because graphing you have to be really precise, and if you're not super precise, it's difficult to see where they cross. Or you can use the elimination or addition method, or you can substitution method. So the next couple, I'm going to say solve by any method. So you choose. By the way, on your test, there are going to be some questions that tell you solve by the addition method. If you don't do it by that method, I'm going to mark it wrong, even if you got the right answer. Okay? You have to follow directions. Same thing as on some of your quizzes. When it said show work, if you just had answers, I'm not giving you credit. So some of you guys missed points on your quiz because you just did no work. Same thing on your homework. Okay? If you don't show work, you don't write down the problems, I'm not giving you credit for taking someone else's answers. Solve by any method. I would like you to solve for number 5. Solve the equation, or the system of equations, 12x minus 3y equals negative 9, and negative 4x plus y equals 3. Solve by whichever method you would like. So graphing, substitution, or addition method. Which method would you guys like to solve by? Addition or substitution? Addition method. Kelly's the only person I heard talking, so we're going to go with her method. So addition method. So what would you have to multiply by? Do you have to multiply one or both of the equations? And which one would you multiply? The bottom one by 3. So multiply everything on the bottom by 3. If you line these up, we have 12x minus 3y equals negative 9. Multiply everything by 3 gives you negative 12x plus 3y equals 9. What happens here when you add these together? Does everything cancel out?
What the heck? Yeah.
If you add all this together, you get 0 equals what?
0.
0. Negative 9 positive 9 gives you 0. That does not tell you that these cross at 0, 0. Okay? If you get two numbers that are equivalent, so 0 equals 0, or you could get negative 4 equals negative 4. If you get a true equation, what that means is, this means there is an infinite number of solutions. This means infinite solutions. Okay, so the answer here is not 0, 0. The answer is infinite solutions. And what that means is that when you graphed these, basically one equation might have looked like this. The other line was the exact same line. So we're trying to figure out, where do they cross? They cross everywhere. They cross at this point, and this point, and this point, and this point, and they cross in an infinite number of points. Yes, Kevin?
Is there a symbol for that?
There is not a symbol for infinite solutions. You just have to write infinite. No. Okay, next one for number 6. Okay, for number 6. I would like you to solve the system 2x minus 3y equals 4 and 6x minus 9y equals 8. 2x minus 3y equals 4 and 6x minus 9y equals 8. Does this look like it would be easier to do substitution or addition method?
Addition.
Probably addition method. Okay, what do you have to multiply one of the equations by? First one by negative 3. So if I just rewrite this underneath, that would be negative 6x plus 9y equals negative 12. If you add these together, what happens? 0 equals negative 4. Will 0 ever equal negative 4? No. So what do you think this means? This means no solution.
Yes.
How do you think it would be possible for two different equations to never cross? Is it possible? Say it again, Kelly. They'd be parallel lines. Okay, so if the lines are parallel, they will never cross. That's what that means. Okay, so if you have a no solution, it just means you have two parallel lines. You get infinite solutions, it means you have the same line on top of itself. Questions on how I did that? Now, this was the Algebra 1 part, okay? Super easy. The part that you didn't do in Algebra 1 was these next two examples, and we're only going to do 2 of them, okay? We're going to take these just to a little bit more difficult level. I would like you to solve 0.05x plus 0.03y equals 0.22. That is your first equation. Your second equation is 0.15x plus 0.18y equals 1.02. Why would you do this?
You didn't do this last year.
You didn't do this in Algebra 1?
2 last year.
Well, you should have.
He
Huh?
was the worst teacher ever.
Who was?
Mr. Fry.
Oh, sorry. Okay. Don't freak out just because there's decimals. Okay? It's going to be okay. If we want to get rid of the decimals, what do you do? All we have to do is get rid of the fraction, or get rid of the decimals. So, how many places do I need to move the decimals over so that they're gone? 2. As long as you move the decimals over the same number of places in each equation, you're fine. So, this first one, it needs to be moved over twice. So do it. Multiply, move it over twice. What is that actually doing? If you're just moving the decimal place over twice, what are you actually multiplying by?
100.
It's the same thing as multiplying by 100, okay? It's just easier to say move over the decimal places. How about the bottom equation? How many times do you have to move that one? 2, okay? It doesn't always have to be the same number of spaces for the top and the bottom equations, okay? So rewrite these without the decimals and it will become a lot easier. So 5x plus 3y equals 22. Your second equation is 15x plus 18y equals 102. Those are the exact same equations, we just got rid of the decimals. So it looks nicer. From here, would you want to do addition or substitution method? Addition, okay. What do you want to multiply the top one by? By -3. You multiply everything by -3, you've got -15x minus 9y equals -66. Now when you add these together, the x's go away. 18y minus 9y gives you 9y equals, what's 102 minus 66?
36.
36. Then divide both sides, y equals 4. So even though you start with these super ugly fractions or decimals, don't worry, you're still going to get normal answers, okay? You do not have to change anything about your answer just because you started with decimals. Then take this, plug in. You can plug into one of these decimal equations, but you don't have to, okay? I would plug into the easiest equation that you can find. So 5x plus 3 times 4 equals 22. So 5x plus 12 equals 22. You subtract 12 from both sides, you get 5x equals 10, and x equals 2. So if you graphed these two equations, they would cross at the point 2, 4. So even though you have decimals, you can get rid of them. Okay, there is a decimal question on your test. So I'm not just doing these to torture you. Okay, and then the last one you're going to do today, since we dealt with decimals, now I'm going to show you one that has fractions. Same thing. We're going to get rid of them. I know these are long, but you're going to be okay. 2/3 x plus 3y equals -34. And your other equation is x minus 1/2 y equals -1. 2/3 x plus 3y equals -34. X minus 1/2 y equals -1. Now, unlike with the decimals you moved everything over 2 decimal places, which basically meant you multiplied everything by 100. When you're dealing with fractions, I want you to keep in mind that you do not have to multiply both equations by the same thing. Okay, it's kind of like when we were doing the addition method ones. If you look back at your notes on number 4, One of the equations you multiplied by 4, one of the equations you multiplied by 3. That's fine. Okay, you don't have to multiply by the same thing. So if you look at this first equation, what would I multiply by to eliminate the fractions? 3, because 3 is what's in your denominator. So multiply every part by 3. You can either put it as a parentheses or you can write it next to each part. Doesn't matter. If you look at the second equation, what would you want to multiply by? A 2 to eliminate the fraction. So multiply everything through by 2. If you rewrite your equations, the reason when you're dealing with fractions, the reason I would write it next to each part is so that it's easier to see what's going to cancel. So you'd get 2x plus 9y equals negative 34 times 3 is negative 102. For your bottom 2x, this goes away, minus 1y equals negative 2. Now that you have these worked out and multiplied through, can you add them together for something to cancel? No, not yet. What do you have to do to one of the equations? Multiply by a negative. Instead of rewriting everything, let's just multiply by a negative. That changes this to positive, changes this to positive. So you don't have to rewrite everything. Then if you add these together, the x's go away. That leaves you with 10y equals negative 100. Divide both sides by 10. Y equals negative 10. Take that equation, or excuse me, take that variable, plug it into another equation. So negative 2x plus negative 10 equals positive 2. If you add 10 to both sides, we get negative 2x equals 12. X equals negative 6. So where would you cross these two equations? What's your actual answer? Negative 6, comma negative 10. So if you graph those two equations, they would cross at negative 6, negative 10. Okay, make sure you write down your homework. It is a little bit spread out. Okay, so you're jumping around a little bit on your book assignment. We will have a quiz on this tomorrow, or block day.